Welcome to Electronics Techie. So in this video we are going to discuss about how to design the RAM. So how you are going to design the RAM using Verilog, just see in this video. So before that first we have to know some simple block diagram of RAM. So what are the inputs and what are the outputs, then we are going to draw the design the RAM. So here we can consider clock. You know that all the clock and reset, so according to the clock it will be going to be execute on according to positive or negative edge. So clock reset, so write underscore enable, read underscore enable. So when you are going to enable these two, then only it will be going to be if they write the means in RAM what you are going to do mainly means, so first we have to write the data into the memory. So whatever the data from user, it will be write into the memory. So for that purpose we are going to use in the, so first of all I write what are the ports, then I explain in detail according to every pin. So what are the inputs: clock, reset, write enable, read enable, and write address and read address. So read address, and what are the output is data out. So data in is also input, so data in. So this is our RAM design. So now I explain everything in detail. So in RAM what you are going to do means, so we are going to do that write operation and read operation. So in RAM, so mainly we are going to do the read and write operations. So what we are done in the write operation, so what is the data, it should be right inside the memory. So what we are having the data, it should be written inside the memory. It is the write operation. So what is the read operation? So read operation means, so what is the content which are inside the memory. So what we are write the data inside the memory, that should be taken from out of the memory. So if you want the data from the memory, you can take it out. So that is the read operation. So what is the main condition means, whenever the write enable is on, then only your write operation is going to be happen. So whenever the read enable is on, then only your read operation is going to be happen. So but one condition is there. So at a time don't enable both the pins. So you have to enable only write enable or read enable. So don't confuse about that. So these are the main points we are going to think about that. So now you are going to design. It is very simple. So just understand everything. So if you have any doubts while I'm explaining, you can comment on it. I make a separate video and small video for that. So first of all, you start with module. It will be common for everything. So module followed by module name. So RAM is our module name here. So what are the input ports? Clock, reset, write enable, read enable. These are the 1-bit ports. So 1-bit memory. That's why I simply write clock, reset like that. So what is the read enable and write enable? Read address and write address. So these are the address. So you have to declare the address where we have to write the particular thing inside the memory. You have to use the write address. So read address means from which location of memory you are going to read the data. So there are so many locations in memory. They have so much of memory space. So what you are going to do, read at particular point, you are going to read the data. So at which location it shows the read address. So write address means at which location of memory you are going to write the data. So that is the write address. So read address, write address. So next is data in. So what you are want to take from user, that will be data is inside right into the memory. So what is the data read from the memory, it should be come into the data out. So these are about the input and output ports. Up to now it will be clear. So now what you are going to do means, you have to create some memory. So then only you can understand, you can pass from inside the means here data in is our input, data is our output. So you can give input and output. What is the inside connection? So if you want to connect something for temporary purpose, so that's why you can take some memory. So how you can take, it's like a array format. So how you are going to represent the array? So already in the data types concept, I already discussed about all the data types, array, range, while those all things, I think. So once check it out. So then also you get confused means, I make a separate video if you comment on it. So here I take reg. So why I take reg means, so whenever we are going to use always block, so what are the variables we are going to use initial or always block, that should be a reg data type. So that's why we are going to make it as a reg data type. So reg. So here what is the array? We all know about 7 down to 0 means it is the vector format. So vector means it has the 8 locations. So 7, 6, 5, 4, 3, 2, 0 to up to 7, 8 locations will be the in the vector format. So what is the array? So if you declare mem of 0 is to 7, so then what will happen means, so it locate like this. Sorry, it will be considered like this. So 0 up to 7. So means 8 memory locations. So what is the meaning of if you write like this? So if you write like this means what will going to happen means, so it has a 7 memory locations, 0 to 7. Each memory locations contain 8 bit of size. So each memory location will consist 8 bit of size. So it is the meaning of this range 7:0 mem of 0:7. I think it's clear. So next integer. Integer of I means, so why you are going to use this I means, so if you want to enter the data inside the memory from one memory location to another memory location, so you can go to step by step. So while you are going to use for loop, so there is a, if you can consider one variable, so it will be an integer data type. So next one, always at the rate passage of clock means every passage of clock your what are the changes will going to happen at only passage of clock itself. So begin. So if reset means what will going to happen, your memory is going to be reset condition means your whatever the data inside the memory will be going to be 0. So what you are going to do for I is equal to 0 means if the whenever the I value is going to be 0, so up to how many memory locations we have? So we have 7 memory locations. So for 7 memory locations the data will completely be 0. So that's why 7 8 I less than 8 means, so 0 to 7. So I less than 8 means, so 0 to 7. I is equal to I plus 1 means every time it is going to be increment, and whenever this condition is false then it is out of the box. So if the reset means ever completely or what is the memory, it should be a 0. So next write operation. So what is the write operation? We already said you can't apply write enable and read enable at a time. So you can't, I already said that in before. So what I said, so you can't write at a time, you can on the write enable and read enable will be high. So what you are going to do, else if it is not reset case, so it is not in the reset case, so what will going to be happen, else if write enable is equal to 1 means, if the write enable means write operation is going to be happen, okay, that's why we can on the write enable. So write enable is 1, read enable is 0. So end, what is this end represent means, so whenever the both conditions is true then only this line is going to be execute. So if you write logical OR, so if you write like these two symbols means whenever your conditions inside those, if any one condition is going to be true, then the next what are the statement is it is going to be execute. 1 minute, I erase all the things, then it is very clear to understand. So it is little bit clumsy here. So see, so logical end means, so whenever the both the conditions what you are write inside this if block, so both the condition is true only, then it is going to be executed. If the read enable is 1, then what will happen, so whatever the data having user, that should be right inside the memory. So where we have to write, it shows by the write address. So whenever the write address, so address of the memory location, mem of what is the write address. So if you write anything, so 0 0 0, so like that, if you write, if you want to write any address, so at that particular location this data is going to be stored. So that is the write operation. So what is the read operation? So read operation, again we are going to write passage of clock. So up to now it is will be the write operations. It will be now from it will be read operation. So always at the rate passage of clock means every time I explain that. So for every passage of clock, your what are the changes it will be going to be happen, then only it is going to be executed. For every negate of clock, it don't consider any changes. So whenever the passage of clock, then only it consider the inputs and changes the output. So if reset, so if the reset is going to be happen, our data will completely be, so whatever we are reading from the memory, so here we are getting the output. So read operation means we are getting the output, write operation means we are giving input to the memory. So what will happen, so the data will going to be 0 if the reset means. So and if and write enable means, we all know that, so whenever the write enable is on, so read enable should be 0. So whenever the write enable is 0, so read enable will be on. So at a time don't on both of the read enable and write enable. So write enable and read, here see write enable is going to be 0 and read enable is going to be 1. So logical end means I already said that. So whenever the both the conditions is true, then only inside it will be execute the inside statement in the if block. So what you are writing? So mem of read. So whatever the data at particular location. So what is the particular location is set by the read address. So read address is going to be set at the particular location. So that particular location data is going to be taken by the user. So data out. So it is our output. So what is the read operation? It will be given to the output and followed by an end module. So this is our design code. So first we have to consider the inputs and create a memory. And if it is a reset means it is going to be 0. Otherwise we are going to write the we are going to do the read operation and as well as the write operation. So at a time both will not going to be happen. First you have to write the data inside the memory, then from that memory you are going to read the memory. So this is the complete process of the design code. I think it's very easy and simple. Try to understand this. If you have any doubts you can comment on it. So simply I move into the test bench code. So first you have to write the module followed by module. So what are the inputs? It should be a reg data type. So what are the outputs? What you are mentioning in the outputs, that should be a wide data type. So RAM. So if you are going to connect from design code to test bench code, so how you are going to connect? By using this line. This is called instantiation. So followed by how you are going to write means, so first you have to write the design code module name. So what is the design code module name? It should be right here, and followed by DUT, design under test. You have to write the instance name. So you can take any instance name, nothing about that only particular thing, you can take any name. So followed by port list. So port list means port list by connection by order or connection by name. I already introduced these all things in previous videos. If you don't watch it, if you go and watch those all things. So port connections, if you are connect those design code ports, and so it is our design code means. So if it is our test bench means there are the inputs, there are inputs for test bench as well as design code. So what you are going to do, you are going to connect these two ports. So for connecting that purpose, you are going to write this line. So these are the port connection by order. So you have to connect those clock reset ports in order. So what is the order in design code? So clock reset, same order will be followed by here. So that means it is the port connection by order. So initial begin. So what you are going to do initially, what are the values that should be, what are the inputs, are all should be 0. I make it here. Here I make the test bench code very easier and simpler method. So that when I am searching about the things, it will be simple and familiar and good, I think. So that's why I choose this test bench. So it gives perfectly. So see here initially all the values are going to be 0. So what is the inputs? Clock reset, write enable, initial all is going to be 0, and always /5 clock equal to for toggle of clock means for every 5 nanoseconds of delay the clock will be going to be toggle means if now present clock will be 0 means after 5 nanoseconds it will be going to be 1, and again it will be going to be 0. For every 5 nanoseconds of time it is going to be toggle like this. So see here next line is going to be initial begin, again at the rate negate of clock. So what it means? So I think it is a new thing till now in my video. So at the rate negate of clock. So what it means so for next negative edge of clock. So now you are so if you are going, if your clock is like this. So according to your clock, so it is a positive edge of clock, it is our negative edge of clock. So here what I am saying here means, so next negative edge of clock. So next what is the negative edge of clock? At that particular point this line is going to be execute means what are the input values that is going to be changed. For this time the reset value is equal to 1. For next negative of clock again your reset value is going to be 0 like that. So it is not about the delays, so it is about the negative edge of clock. So at present particular point some values is going to be changed. So again next negative edge of clock it is going to be changed. So like that. So here next negative edge of clock it will be reset value is 1, and again negative edge of clock it is going to be 0. So now next negative edge of clock what you are going to give? Write enable. So what about read enable means first initially you are giving it as 0. So it will be continued like this. So what are the changes? Then only it is going to be changing. So write enable is going to be 1, write address we are giving 0 0 0. You can take any address, and data is what you are going to give that particular data, that should be give. Here I give A. So 1010 means A. So I give 21010, so that's why it will be A in hexadecimal. So next negative of clock, your write enable is going to be 0. I already said that both the write enable and read enable not will be in the same at a time, not will be in high. So that's why you are going to be and disable this write. So enable write here. So we are disable write here. So next negative edge of clock what you are going to give? So read will be enable, also on high. So next we are going to the read address. So at that particular location we are going to read the data. So what is the at this particular letter what is the data? Here only we write A. So that A is going to be executed into the data out. So again your read operation read will be disabled. So for next negative of clock your execution is going to be finished. So this is your test bench code. It is a different manner of writing test bench. Try to understand this. If you have any doubts, you can comment on it. So next 4 lines is used to generate the EDF, generate the waveform in EDF playground, followed by end module. So this is our simulation. Try to understand in detail. So see here, first I mentioned only pause edge of clocks here. So first, what I say first, initially we are make it all as zeros. So that's where clock will be 0 and data will be 0. So data out means it is not any write-enable and read-enable. That's why it simply take don't care. So just neglect about that. So read address is 0, read enable is 0. So all will be going to be 0 initially. So what will happen? So next negate of clock. So when it is your negate of clock here. So see these line, your next negate of clock, your reset will be going to be 1. So here we can reset will be 1. So next what will happen? So whenever the reset value is going to be 1, so then your data is going to be 0. Okay. So next negate of clock, again your data is going to be 0. So your reset value is going, your reset value is going to be 0. So next what will happen? So you are going to write for next negate of clock. See here at this particular point. So 1 minute, I erase these things and make clear about that. Here I draw the dotted lines for negative edge, then it is very clear to understand for you. So here is one, it is a pause edge. So here is one negative edge. So here is one negative edge. So here is your one negative edge. So now understand according to the test bench. First initially all will be 0. So for next negative edge, what is going to happen? Reset value is 1. So see here at this particular point your reset value is equal to 1. So it will clear itself, I think. So for next thing, see here, for next negative edge of clock, again your reset value is going to be 0. So again your reset value is going to be 0 for next negative edge of clock. Okay, here also it will be fine, I think. So at this particular negative edge, it will be going to be 0. So next what will happen? So for next negative of clock, so reset will be continuous 0 and other changes will be write enable is 1, write address and data. So 3 changes will going to be happen. So see here for next negative edge of clock. So this is the next negative edge of clock. Your read enable is write enable is 1. So and the data will be 10101010 is nothing but AA. So your data is also going to be changed here. So what is your write address? So write address is 000. So that's why it will be 0 itself. So these are the changes. So next negative edge of clock, what is going to be happen? Your write enable is 0. See here for next negative edge of clock at this particular 40 nanoseconds, your write address will be 0. So okay. Next what will going to happen? Your read enable is going to be 1. And read address is going to be 0. So for this thing, your read enable will be 1. So now you are going get down. In previous you said that whenever the read enable is going to be on, your data will be 0. Your data will be going to be at the, what is the data? Here the data out is going to be 0 only. So whenever the read enable is 1, so your data it should be whatever the inside of what you are going to take the input. So it should be AA. So why it is going to be 0? I already said that whenever the positive edge of clock, then only the variables we are going to assign that should be done. So data underscore out, it should be assigned at the positive edge of clock according to your design code. So I think it will be clear. So it will be next negate of clock, your read enable is going to be 0. See here, your read enable is going to be 0 for next negate of clock. So like that you can design the code and try to write the own test bench for your design code, and you can analysis about how you use your design code and test bench according to your waveform. It will be correct or not. If the reset is given, it will be 0 or not. Otherwise it will become data out or not. It will give don't cares or something any else if there are any errors, any debugs. So try to understand if there is any error also, it will be good for you because you know the what type of errors is going to be get. So when you are going to study the different types of errors, so then you can work out on those errors and try to solve those on. Then it will be more efficient and you get good knowledge on that particular language. So if you get any errors, don't try to stop at that point. So you have to try to in any online platforms, and then also you don't resolve, you can comment on it. I can also try for that particular thing. If I don't know also, I also try to solve from particular thing by using any guidance. So thanks for watching, thanks for keep supporting me, and I think it will be fine. So and then bye.